All right, everybody, let's try to wrap up our notes on section 11-3. I told you there's just one more example. I set the format up a little differently, so hopefully things will work out and be less frustrating for me, less frustrating for you. Okay, last example, example 4. Find the derivative of this function, f of x equals the square root of x. Okay, so first thing we do is we use our derivative formula. And I've got that over here. It's a limit as h approaches 0 of f of x plus h minus f of x all over h. And remember, the first thing we do is we plug x plus h into this formula right here in place of x, okay? And that gives us, instead of the square root of x, it's going to be the square root of x plus h. Then minus f of x means minus this original function. Okay, so we plugged in x plus h minus the original function, and still all over h. Okay, so once we do that, we need to simplify this. Now, simplifying this is no small matter because we need to, well, if we plug 0 in place of h, we'd get 0 over 0. That wouldn't work. So we need to do something to simplify this, but it goes back to one of the limit problems that we did in a previous unit. So what we have to do is we have to rationalize the numerator. So we'll put this entire top in parentheses. We need to distribute what's on top. So you multiply every term on the top by this conjugate over here, which is the same terms with a plus instead of with a minus. So if we do this multiplication, multiplying the first two terms, the square roots are just going to go away, x plus h. Multiplying the outer two terms, we have square root of x times square root of x plus h. Multiplying the inner two, we have negative square root of x times square root of x plus h. Those are going to add to 0, so I'm not going to write those down. The last two terms, multiply those, we get minus the square root of x. So if I pull this down here, distributing gives us on top x plus h. The outer and inner add up to 0, so I'm not going to write those down, minus x. Now on the bottom, we could distribute that h by everything, but don't bother because you'll see something else is going to happen in just a bit. Okay, now here's what you should notice. You should notice on top, hey, we have an x minus an x. That's wonderful. Ooh, now you notice there's an h on top and on bottom. If we divide out those h's, but careful when you divide those out. Sometimes people say, well, there's nothing left on top. But since we divided out the h's, there's really a 1 up here. Okay, so here's what that leaves us. Let's clean that up a little bit. So that gives us the limit as h approaches 0 of 1 on top over the square root of x plus h plus the square root of x. And at this point, we can use direct substitution. We can put 0 in place of h. Well, if we do that, we get, well, 1 stays on top. This becomes the square root of x plus the square root of x. Well, the square root of x plus the square root of x, we can just write that as 1 over 2 times the square root of x. And this right here is our derivative of our original problem. Okay, so practice finding some derivatives. You're going to have to find the derivative of a square root problem on your test. You're going to have to find the derivative of a polynomial, something like example 3 on your test. So make sure you know how to do each of those. All right, you guys, thank you for bearing with my notes. It was a little crazy there, but if and when you have questions, please reach out via email or stop in to one of our office hours for one of our meetings, and we'll gladly help you out with anything you have questions on. All right, take care. Good luck with this.